All right, so I'm going to change this problem up a little bit and say this was the position function, not the velocity function. Now, this is a time where they could have actually asked you the total distance. So we're going to look at that. By the way, if it was net distance from 0 to 3, that's easy. That's just displacement. That's where you ended up, position at 3, minus where you started, the position at 0. So that would be net. That's easy. Plug it in, subtract. Total distance is a little bit more complicated because total distance takes into account everywhere that you change directions. So the first thing you need to do is find out where you change directions by finding out where the velocity changes signs. Notice you don't have the velocity here. You could differentiate that using the product rule and then find out where it equals 0. I'm going to do it, and I don't suggest doing it this way, but just for sake of time, I'm going to do it by having my calculator kind of calculate the derivative and graph it. So what I did was, to make this velocity, I went to math. First of all, y equals the math 6. All right, on this calculator, it's n deriv. That gives me this whole derivative thing. Type in the function. So derivative of this function, that would be the velocity. But I want it to do it at every value of x. So I'm going to put x equals x, graph it. So now they're graphing the derivative of this function, which is the velocity. The velocity, which it's graphing now, changes directions everywhere it crosses through the x-axis. We're only interested from 0 to 3 here. I'm going to change this window from 0 to 3. And it goes through 0 right there and nowhere else from 0 to 3. So let's calculate this 0. Left bound, right bound, enter. So this says the particle is going from left to right at x equals 1.8732. That's what I said. So to calculate the total distance, you need to figure out, first of all, where you were when it started, which was the position at 0, where you were at the first change in direction, and finally where you were at the end, and you add all of those net distances together. So going back to the calculator, let me get rid of this ddx, and there we go. That's now my position function. Except I got rid of the negative, it looks like. Insert that back in. So assuming I did this correctly, typed it in correctly, I'm going to now get the values at all of these values. So x of 0 is 0 because the graph looks like it's 0 and the sign of 0 is 0. I don't need to worry about that. The value at second calc value at 1.8732 is negative 2.8248. And now figure out what the value at 3 is. 3, enter. 3.9101. So to get the total distance, you add up all the distances in each leg here. So from here to here, your total distance was exactly 2.8248. Plus, add the distance from here to here. Remember, you're going from -2 to +3, so your total distance is going to be 3.9101 plus 2.8248, which is 6.7349. That's from here to here. So you have to add up from here to here and here to here. So add those together. Plus 2, giving you a total distance of 9.55. You can just look at that. 9.5597. So I don't know if they're going to ask you that, but they can, because it only has to deal with derivatives. So that's how you would manage that.